بسم الله الحمد لله والصلاة والسلام على رسول الله. الطلبة الأعزاء، السلام عليكم ورحمة الله وبركاته، وأهلا ومرحبا بكم في هذا الجزء الثاني من المحاضرة الثانية للمحور الأول الذي بعنوان Alignment of Views. نبدأ بالprojection systems. We have two systems for projection. First one is called first angle system, used in European country and ISO standard. الثاني هو third angle system used in Canada, US, Japan and Thailand. If we divide the space for 4 quadrants, this is the first quadrant, this is the observer. And this is the third quadrant with the observer. First angle system and third angle system. We have an object in the first quadrant and the third quadrant. The observer from here, he can see the object and the views will be projected from the backside. This surface. Now this surface will be projected here. Okay. Now for the third angle system, the observer watch the surface and will be projected from the front and the front surface. Here also this surface will be projected here, this surface will be projected here. The side view now for the first angle, by the same way, this surface will be projected in front. It is the back side of the object. Now, this is dashed line. Okay. Now for the third angle system, this surface will be projected from this side, front to the object. I mean between the observer and the object. Okay. This will be dashed. This is side view. Now from the top, by the way, this surface will be projected down. This surface will be projected down also. Here for the third angle system, this surface will be projected in the top and this surface too. This is the difference between projection in the first angle system and the projection in the third angle system. Now we want to open this glass box to see all views in 2D projection. Okay? Okay. This is 2D presentation. Same for third angle system. This is 2D representation. With more details, here the difference between first angle system and third angle system when projected on 2D representation. This is the front view in the first angle system. This is the front view in the third angle system. This is the top view and this is the right side view. For the right side view in the first angle system, we have to see from the right side and draw the right side view in the left side. For the top view, we have to see or watch the from the top and then draw it down. It will be the same for the left side view. We will have to see by the left side and draw it in the right side. For the bottom view, we have to see from the bottom view and draw it in the top. For the third angle system, right side view, we have to see from the side view, right side, and draw it in the right side also. For the top view, we have to see from the top and draw it also in the top side. It will be the same. For this left side view, we have to see from the left side and draw it in the left side. From the bottom view, we have to see from the bottom view and draw it projected in the bottom side. Projection symbols. For the first angle system, symbol for both, the symbol will be a cone, but the projection is different. For the first angle, this is symbol. First angle, we have to, for the, this is the left side view. We have to see from the left side and draw it in the right side. Okay, for the third angle system, okay, this is the left side view. We have to see from the left side and draw it in the left side too. Suggested proportions. So the symbol have to be drawn by using these proportions. This is diameter d. The big diameter should be 1.7 small d, and length of cone should be 2.2 d.
Okay students, welcome to part 2 of orthographic projections for topic 3 in your MM101 Engineering Graphics and Design. Let's look at something called principal planes. When we try to describe a object in 3 dimensions, it is very important to first of all understand what these principal planes are. For example, if you have a 3-dimensional object, then we imagine there are imaginary planes surrounding this object. Okay, so this object we have shown here is a piece of a 3D solid, and as you can see the XYZ axis is there. Now let's look at what these principal planes are. The first principal plane is the horizontal plane. Okay, so this is horizontal in nature and it extends infinitely. So we imagine the plane to have no end as well. So it's a horizontal plane. The other principal plane is a vertical plane. And finally, we have a profile plane. And these are all imaginary planes, and we imagine our object being surrounded by these planes, so that when we describe the object, we can draw the projections onto these planes and then draw them on paper. Okay, so let's move further. Now, once the horizontal and the vertical planes cross each other, the space is divided into 4 portions. Namely, we have the first quadrant, the second quadrant, third quadrant, and the fourth quadrant. This is very, very important. The first quadrant, second quadrant, third quadrant, and the fourth quadrant. These are formed when you pass a horizontal plane and then intersect it with a vertical plane. You get first, second, third, fourth quadrants. Basically, space is divided into 4 portions. Let's look at the first quadrant again. That's the first quadrant, second quadrant, and finally the third and the fourth quadrant. So that's what we call first angle projection. Whatever is projected onto that plane in the first quadrant is called first angle projection. Whatever is projected or drawn in the second quadrant, we'll come to the drawing later, is called the second angle projection. And whatever is drawn in the third quadrant is called the third angle projection. And whatever is projected onto the fourth quadrant planes is called the fourth angle projection. Okay, so you can see HP stands for horizontal plane and vertical plane. So these are horizontal and vertical planes, and these are the angles of projections that we have. Now the rule for the horizontal plane is that the horizontal plane folds clockwise. Okay, so we will now see how only the first and third angle projections are useful, and the second and the fourth are not so useful. This is because the horizontal plane will fold clockwise, and if, for example, this plane was to fold clockwise, this is what will happen is the second quadrant will fold on itself, and the same will happen for the fourth quadrant. Okay, so that there will be views on the projections, but the views will collapse on itself. So the horizontal and the vertical planes will basically fold onto each other. and you won't be able to see any projections. The only places where you'll be able to see any projections is the first angle projection and in the third angle projection. Let's move on. Let's look at first angle projection or first angle orthographic projection. Let's imagine this object here, and it is encased by let's say a glass box to say. Okay, so to make things easier, let's get rid of this glass box. Okay, and let's look at projections. What is a projection? First of all, as we have discussed in part 1, projection is basically whatever the image is of the 3D object is projected onto the plane. Okay, so in first angle we draw the projection on the furthest plane from the view. For example, let's look at the front view. You see the direction of the arrow, you're looking at it from one side and drawing the view onto the plane on the other side. Okay, so it's as if it's a shadow of the object. Okay, so what we say is the viewer is viewing the object and drawing it on the furthest plane, or you can say the object is in between the viewer and the plane. Okay, let's look at left hand view. This is how it will look from the left hand side, but we're drawing it on the right hand side plane. Similarly, if you look at it from the top, you don't draw it on the top, you draw it at the bottom. Okay, as if it is the shadow of that object. So that's why we say the object is between the viewer and the plane, and the view is drawn on the furthest plane from the view. Okay, so if I was to fold this box up, okay, the horizontal plane folds clockwise, and you will get something like this. Okay, so you have the front view, the bottom view goes on top actually, and then you have the front view, which is the front view sitting on top of the top view. So the top view is not in the actual place. In fact, in the first angle orthographic projection, all the views change places. So the right side view sits on the left side, the left side view sits on the right side, the front view is on top of the top view, and the top view actually goes to the bottom view appears on top. Okay, so the main here is mainly the front, top, and the left and the right side views. Things will become much more clearer once we look at the third angle orthographic projection and we do some more exercises. So hang in there and have a look at part 3 of this lecture. Okay students, welcome to topic 3, orthographic projections, and this is part 3 of your 3-part video lecture series on orthographic projections for MM101 Engineering Graphics and Design DFL. Okay, let's recap what we have done so far. We have looked at the basic principles of orthographic projections. We have looked at how the quadrants are made. We have looked at why the first and the third quadrants are the only useful projections. So we have the first angle projection and the third angle projections. And in the previous part 2, we have looked at first angle orthographic projection. Now let's look at third angle orthographic projection. Okay, so let's imagine the box being the same, a glass box, but now this time around we know this box is now located in the third quadrant. It's no longer located on the top first quadrant, it's now in the third quadrant. So try to imagine where the third quadrant would be and how this box would be located. Okay, so now let's look at this box in the third quadrant and we try to make projections of this solid object onto the planes. Remember, the views that you're getting are actually the projections of this solid object onto the planes. The planes are basically the sides of this box. Now in third angle orthographic projection, the rule is very simple. The plane that you're viewing from, there is the plane on which the views will go. So if you're viewing it from the front, your view will be made on that plane itself. So we say we draw on the nearest plane. Okay, so for example, if I'm looking at this in this direction, looking at it in the frontal direction, then I would have a view, the front view rather, on the nearest plane. And in some cases we like to say that the view or the plane is in between the viewer and the object for third angle projection. Let's look at a the left hand view this time. You see, looking at it from the left hand side, the view will be made on the left hand side. Let's get the extra detail there. Okay, so this is how the basic principle differs in terms of third angle projection and first angle projection. In third angle is very straightforward. The left hand view is drawn on the left hand face as well. And the top view, can anyone guess where the top view will go? Yes, exactly. Top view will go right on top. And now that we have the top view as well, now let's look at unfolding this plane. Remember, the top portion of this glass box represents the horizontal plane because it's located in the third quadrant, and when it's going to fold in a clockwise direction. That's going to form something that will be very, very important and give us the third angle orthographic projection. Now let's see how it's going to fold up. So we got the top view, the front view, and we have the right hand side view. Now what's written here, it says horizontal plane is on the top in the third angle. Okay, so this is the horizontal plane, the one with the top view, is going to open towards us, or you could say it's going to open clockwise. This fold line between the top view and the front view is actually the intersection line between the horizontal and the vertical plane as well. So let's see when it folds up. So when it folds up, this is what happens is when it folds up, this view is what we get. We get the top view on top, the front view, the left side on the left side, the right side on the right side as well. And if you want to go into more detail, you have the bottom and the back view as well. Normally 3 or 4 views are quite sufficient to give details of any mechanical component or part that you want to describe. In certain cases 2 views might be sufficient as well if it's a very simple part. In most of our simple conversion from isometric to orthographic views, we'll be looking at 2 to 3 views. So it's very important for us to understand that how the views are laid out, or how the orientation of the views are in third angle orthographic projections. You have the top view on top, front view at the bottom, beside the front view you have the left side on the left side view, and the right side view on the right side as well. Okay, so just quickly recapping the differences between the first angle projection and the third angle projection. The object is imagined to be in the first quadrant in the first angle projection. In the third angle, the object is imagined to be in the third quadrant. Now we see the object is between the observer and the plane in the first quadrant, and in the third quadrant the plane sits between the observer and the object. Okay, and the plane of projection is assumed to be non-transparent in first angle, so we have like a shadow, and in case of third angle orthogonal projection we assume it is transparent, so we can see the other side of the plane and project that image onto the plane itself. This is something to remember is the symbol. Okay, look at the first angle orthographic symbol, and that is the third angle orthographic symbol, and this picture here really summarizes it nicely. This is the first angle projection, and you see the viewer looking at the object and drawing it on the furthest plane. Here the viewer is looking at the object and drawing it in the plane right in front, where the plane comes in between the viewer and the object, and you see the difference in orientation of the drawings. Now, which one do we use? The first angle orthographic projection, or do we use the third angle orthographic projection? Well, according to our drawing standards, we are going to use the AS 1100 101, the Australian drawing standards. It recommends that we use the third angle orthographic projection. So that is what we will be using, the third angle orthographic projection. However, it is very important that you understand how to draw in first angle orthographic projection as well, because certain parts of the wall do require that you draw per standard in first angle orthographic projection. So looking here once again, In third angle orthographic projection, this is how the orientation will be. Top view on top, just below the top view you will have the front view, the left side view on the left side, and the right side view on the right side. And obviously do not miss this symbol which will indicate which angle of projection you have.